Hey, we're going to go ahead and take a look at systems of equations and systems of inequalities in Unit 2, Section 1. Now, a system of equations is a set of equations with the same variables. So it might be two variables of, say, x and y, and then you have to have two equations with those same two variables, and then you can go ahead and solve that. Now, a couple of words that go along with this is a situation where they are consistent. A consistent set of equations has at least one solution. Means it could be two lines that cross at one point, or it could be two lines that when graphed end up being on top of each other and being the same line. There's also then inconsistent, which means they wouldn't have anything in common, so they would have no solution, meaning it would have to be two parallel lines. We also have the word dependent and independent. Independent means a system of equations that has exactly one solution. Now, if you are graphing a system of inequalities, so once again, up here we were talking about a system of equations, so you have to have an equal sign. But if you have an inequality, if you graph two different inequalities on an xy coordinate system, your answer is where the two shaded regions overlap, because when you graph any inequality, you need to either shade above or below the line that you are graphing. So, as we look here, if we take a look at this first one, right here, we would know this is your y-intercept, this is your slope. So you could start at -4, then you go rise up 11 over 7, and then you could graph in your line. When you graph this one here, you would start at +4, and then you would rise up 3, go over 7. So up 3 over 7. And so then you could draw that in. Then your solution is actually the coordinates of this point of where they cross. Whenever you're graphing equations like this here, your answer will be the point where they cross. Now, on these other ones right here, they're inequalities. When you graph inequalities, you're going to be graphing a line. You're going to start at -1, and then your slope is up 2 over 1, up 2 over 1. And when you plot those points, it would be like this here. So now, because this line, we are looking for everything greater than what we just drew for our y's, and y goes up and down, that means we'd be graphing and shading above our line. So if we take a look at the next one, this is our y-intercept, and this is our slope. So we'll start at a height of 3, and then our slope, which is really -2 over 1, we go down 2 over 1, down 2 over 1, down 2 over 1, and so on, and then you graph in your line. But because when we look at our inequality here, there's no equal to, it's only a greater than, you need to graph it with a dotted line versus a solid line like on the last one. And then once again, when you look at your blue shaded inequality, you want to know what's above that. And so then you're going to shade above that blue dotted line. And then remember, your answer is only where they overlap. And they only overlap at the top part. So I'm going to go ahead and erase this stuff where they are not overlapping. And then your answer to this system of inequalities is only where they overlap. And it's not wanting to erase great, but I think you get the idea of what's going on here. So your answer is really just all this shaded region where they overlap. So if you do end up shading extra like I did, I would shade really lightly to begin with so that when you have to erase where it's only shaded in one region, it doesn't take much. So the other inequality in the far right of the page here would be a same type of situation. So let's go ahead and work through solving these. Now, remember, we talked about these words before. Typically, you're going to go ahead and identify systems as consistent and independent, consistent and dependent, or inconsistent. Now, just to clarify, if it's consistent and dependent, it's two lines that cross at one point, and your answer would be the coordinates of the point where they cross. Consistent and independent would be two lines that end up being the same line, and they'd have infinitely many solutions at work. Inconsistent means they don't have any lines and they're parallel, so they would be like this and have no points in common. So we looked at this one earlier, but we're going to graph this in a little bit more detail. This first or last number here, when y is on one side by itself, is your y-intercept. So we're going to start at -4 for our height. And then our slope is this right here. Remember, slope is rise over run. So you will have to go up 11, right 7. So up 11 is right there, and then right 7. And then you'd want to go ahead and draw in a line going between those 2 points. Then we'll go ahead and graph this one. This one here says start at a height of 4 because y is on one side by itself. That number that's being added or subtracted is your y-intercept. So we'll start at a height of 4, and then we have our slope, which is this, the number in front of x, which is rise over run. So up 3, right 7. So here I'll go up 3, right 7. Or I could go down 3 and then go left 7. And then I'll draw in my line. Then your answer, your solution, is the point where they cross. So this is where you want to go ahead and have fairly accurate graphing. And they cross here at the point 7 to the right, which is your x, and 7 up, which is your y. That would be your solution to this system by graphing. Well, we then also need to go ahead and describe it as consistent, dependent, independent, and so on. Since they cross at one point, we would say it's consistent and independent. Well, on this one here on the right, we want to do pretty much the exact same thing. So I'm going to go ahead and get y on one side by itself. So looking at this first one here, I get y on one side by itself, solving it for y. I end up getting an x plus 5. So my y-intercept, when y is on one side by itself, is what's being added or subtracted to the x. And then your slope is the number that's in front of x, which is 1. So you go up 1 over 1 and plot those points. Or you can go down 1, left 1 and plot those points, and so on, and then draw in your line. Then we want to go ahead and solve this one here for y. And then divide by the -7. So when y is on one side by itself, the number that's being added or subtracted is your y-intercept, and the number in front of x is your slope. So up 1, right 7. Or down 1, left 7. And then you draw in your line. Then once again, your answer is where they cross. So you'd write that down, coordinates of a point, left 7, so that's your x, down 2, so that's your y. And since they cross at one point, it's going to be consistent and independent. Then we want to go ahead and graph our system of inequalities. So once again, we have y on one side by itself for this first one. So this is our y-intercept. Start at 1. Our slope is what's in front, which is 2/3, so up 2 over 3. Or we could go down to left 3, down to left 3. And then because it's a less than or equal to, it's going to be a solid line. So we'll draw that line in. When we look at this, it's less than, so y, when y is on one side by itself and it's less than, then you shade below the line. So it's going to be down here. Then we want to go ahead and graph the other one. Once again, when y is by itself, this is your y-intercept, and the number in front of x is where your slope is. So up 2 over 1, up 2 over 1, up 2 over 1, or down to left 1. And then you draw in your line. It's going to be a solid line because of the equal to. Now, because your inequality is y is greater than, that means you want to be shading above the red line. But remember, we only want to be concerned about where they overlap. So I'm just going to be shading above the red line until I get to the blue, because remember, we had to be below the blue, but the second one says we have to be above the red. So then I'm going to come along and get rid of some of that shading I didn't need. And so then your answer is that shaded region. With 28, it's pretty much the same thing, except we have to do one extra step of getting y by itself. So get y by itself in each one, and then go ahead and graph these. When you're getting the top one with y by itself, subtract an x, and then you divide by a negative. Now remember, when you're dealing with inequalities, if you divide by a negative, you need to switch your inequality signs. So when y is on one side by itself, the number that's added to is your y-intercept, and then our slope's what's in front. So up 1 over 3, up 1 over 3, down 1, left 3, down 1, left 3, down 1, left 3, and then draw in your line. Now, because it's not a greater than or equal to, it's only a greater than, you need to make sure it's a dotted line. Once y is on one side by itself, we want the y values, and remember y goes up and down, that are greater than our line that we just drew. So you're going to do a light shading above. And then we're going to go ahead and do our other one. Get y on one side by itself. Divide by the 3. We're dividing by positive, so we don't switch our inequality sign. So when y is on one side by itself, the number added or subtracted is your y-intercept. Your slope is rise over run, what's in front of x, so down 4 and right 3. Down 4, right 3. Or we can go up 4, left 3. Up 4, left 3. Up 4, and left 3. And then draw in your line. Because we have a greater than or equal to, remember it's going to be a solid line. Now, because we had a greater than, that means you need to be shading above the red line. But remember, we only want to shade where they overlap, so it's above the red line, but only over here in this region here. So then we need to go ahead and erase this little bit over here that we didn't need. And that's your solution to your system of inequalities.